hot dog, hot diggity dog. It is day 12 of our AP stats video making.
Did he say 12? My God.
And today, remember, we're just going to be looking at some extended response questions that go with sampling distribution. Now, remember, the entire AP test is now extended response. So it is super important that we go ahead and try to do these types of questions, all right? So we're going to jump right in. This is just a review that I've kind of put together that cover some of the types of situations that we've been talking about with sampling distribution. We're going to look at, I think it's 4 or 5 questions, but some of them have multiple parts.
Why they always gotta have multiple parts?
We're going to move fairly quickly through it because at this point we've kind of discussed a lot of the content a few times. So I want to make sure that we get through as much of this as possible. So jump right in. It says it is generally believed that electrical problems affect about 14% of new cars. An automobile mechanic conducts diagnostic tests on 128 new cars on the lot. A. Describe the sampling distribution for the sample proportion by naming the model and telling its mean and standard deviation. Justify your answer. So this actually is a little bit longer of a question than it seems like, but not too difficult. All right. So it says describe the sampling distribution for the sample proportion by naming the model. What's the model? Well, we know that if we are dealing with a sampling distribution, as long as our conditions are met, which we'll get back to in a second, then we are following which model? The normal model. So that means that really this is just asking you to make mention of the fact that it is a normal model. All right. Then it asks for the mean and the standard deviation. Remember, the mean that we use in this case is just whatever the true proportion is. So that would be 14% in this case, or 0.14. The standard deviation, not as easy. Standard deviation, remember, is going to be the square root of p times q divided by n. So if we're looking at 14 as our p and 128 as our n, then we're going to need to plug those in to find our standard deviation. So let's go ahead and do that. So 14 and 128. So we are going to do control square root. Then we're going to put in, that's 0.14. That's our p times our q, which is 100 minus 14, so that's going to be 86, so 0.86 in this case. All right, and that's the top, so I'm putting that in parentheses, divided by our n, which, what did we say n was? We said it was 128, so divided by 128, and we hit enter, and that tells us that our standard deviation is 0.03067. So we put 0.03067. So that is our model mean and standard deviation. It does mention justifying our answer. What does that mean? It simply means it wants you to check and make sure that the conditions are met. So what were our conditions for the proportion? Well, we have to know that they were randomly chosen or independent. In this case, you can assume that it was independent because he's just doing it on 128 new cars. More than likely, one's not affecting the other. So you could say that that one's bad. In terms of p times, or the, what do you call it, success fail, we need n times p. So 128 times 0.14 gives us 17.92. So that's bigger than 10, which means obviously the 128 times 86 is also going to be bigger than 10 because 86 is bigger than 14. So it passes the success fail. You would assume 128 is less than 10% of all vehicles, so that one should be covered as well. So we meet our conditions, and by stating that we met our conditions, that would be justifying your answer. Now, I know I'm not writing it all out because it's really hard to write on a computer screen sometimes, but you could just go ahead and write those conditions, and then you could either just do a check mark next to them or say that they pass or whatever. You could list the conditions and say we've met all the conditions, so that justifies the use of this model. All right. So that would be A. B says sketch and clearly label the model. So if this is our normal model, remember, if we just want to sketch and clearly label it, that means that we want the 0.14 here in the middle. Obviously, we're not going to have much room for writing here since this is a very small area. But how would we go about doing this? Remember, you would just add this to the 0.14 to move this way and subtract this to move backwards. So if I wanted to do 14 plus the 3 here, I'm just going to go to 2 decimal places since that's all that's really going to fit in my picture. Then that means that 0.17 is going to be that guy, and 0.20 is going to be that guy. You may want to go one more just because by most means we always see 3 standard deviations in either way. So that would be 0.23. And to go down this way, you would do the 0.11 because 14 minus 3 gives you 11. Minus 3 again will give us the 0.08. And the last one down here is going to be 3 less than that, which is going to be our 0.05. So again, you could even make it a bit easier by saying that the mean here is going to be 14. And you could say that the standard deviation of our sampling distribution is going to be the 0.03. That should leave no room for error there. That would be providing the absolute maximum that would be needed to get full credit on a question like that. Last part says, what is the probability that in this group, over 18% of new cars will be found to have electrical problems? Now notice it says, what's the probability that in this group, 18%? So this is a sampling distribution question, so we'll be using our new standard deviation, not the old one, all right? So the 0.03067. So let's go ahead and switch over to our calculator here. We want to know over 18%. So in other words, 18 is going to be a lower bound, and we're going to go up to the 9999. So we want menu 55. We're going to go to normal CDF. We're going to go from, what was it, 18? Yes, 18%, so 0.18 up to the 999 rule. And our mean in this case was 0.14. Our standard deviation was 0.03067. And we're going to hit OK. All right. Now, here would be our answer. This 0.096082. So 0.096082 would be the answer to this question. So it says, what's the probability that over 18% of the new cars, it would be a 9.6% chance of happening. Now, you could make this a 9.6%. Or since in this case it doesn't clarify that it's percent, it just says the probability, you could leave it as that original decimal form. So that would be all of question 1. This would give you full credit for it. A lot of times you do want to say like what it is you put in your calculator. So maybe you guys want to start getting used to writing down how you would do it. So maybe you would put, hey, in the calculator I did norm CDF, and just write down some of the stuff that you put in there. So that would be the 0.14. We had a standard deviation of 0.03, and we went from 0.18 up to the 999. All right. Then they at least know where that answer came from. So that would count as showing your work in this case. You don't have to write it all out. You can write simply what it is you plugged in your calculator. So let's go ahead and move on to the next problem. Question 2 says that a herpetologist, a snake specialist, found that a certain species of python have an average length of 20.5 feet with a standard deviation of 2.3 feet. The scientists collect a random sample of 30 adult pythons and measure their lengths. In their sample, the mean length was 19.5 feet long. One of the herpetologists fears that the pollution might be affecting the natural growth of the pythons. Do you think the sample result is unusually small? Explain. So this is one of those questions where we are going to be looking basically at what the sampling distribution would look like. And then we're going to see if that 19.5 is unusually far from where it should be, okay? So starting off, if this is a sampling distribution that we're going to be dealing with, all right, that means we need to find the mean and standard deviation of our sampling distribution, okay? So let's go ahead and write that over here just so we have it ready to go. The mean actually doesn't change. And remember, this is the mean that we know the population has. So that's going to be the 20.5. Don't get it confused with that 19.5. That's our actual mean of our sample in this case. So we don't want to mix the two of those up, all right? Then for the standard deviation, remember, how do we find the standard deviation of a sampling distribution? Well, this is quantitative data. There's nothing to do with proportions here. So we're looking at the original standard deviation divided by the square root of our sample size. So in this case, that's going to be 2.3 divided by the square root of our sample size, which is 30. So if we go ahead and plug that in, we end up getting 0.419921. All right. So that's going to be our standard deviation, the 0.419921. So then in that case is the 19.5 unusually small, okay? Now, the best way to find out if it's unusually small, the quickest one, is probably to find the z-score for it. That's a little bit faster than the whole plugging it in and finding the exact percentage and basing it off of that. You could do a normal CDF question for this, and you would want to go from the negative 999 up to the 19.5. You could go that route and get an answer there. But let's just go ahead and find the actual z-score here. So remember, how do we find z-score? We do x minus the mean divided by the standard deviation. And in this case, since we're dealing with the sampling distribution, we want both of these to be for the sampling distribution as well, all right? And then we go about getting our answer. So in this case, our x is our 19.5. Our mean is our 20.5. And our standard deviation will be using the 0.419921. So if we plug that into the calculator, what do we get? 19.5 minus the 20.5 is just the -1, all right? But we still need to divide that by the 0.419921, and that's going to give us negative 2.3814. And I'm just going to put negative 2.38 because that will prove our point up here. So remember, we actually said that things are unusual if it's outside of 2 standard deviations, okay? In this case, it is more than 2 standard deviations away. It's 2.38 standard deviations away. So that means that if this were a normal curve, that means we are somewhere down here and lower, all right? So if this was the negative 2.38 mark, we are here or lower, which does make us unusual. Remember, if you're more than 3, then you are extremely rare. But in this case, we're just going to list ourselves as being unusual, which is all it asked about. So you would say, yes, this is unusually small. And for the explanation, you would say, because it's more than 2 standard deviations away. Cool? Great. Awesome. This last question is actually a bit of a doozy. Number one, it's very confusing in the way that it's worded. And number two, it actually covers 3 completely different parts of this course that we've looked at, but it is a really great review for us to be looking at. So when we're going through this one, let's first off read the question and kind of look at what we're going to do after that. So it says the depth from the surface of the Earth to a refracting layer beneath the surface can be estimated using methods developed by seismologists. One method is based on the time required for vibrations to travel from a distant explosion to a receiving point. The depth measurement, m, is the sum of the true depth and the random measurement error. That is m equals d plus e. The measurement error is assumed to be normally distributed with the mean being 0 feet and the standard deviation being 1.5 feet. Okay, it says if the true depth at a certain point is 2 feet, what is the probability that the depth measurement will be negative? All right, now what is so hard about this? Well, look at what it's saying. It's saying it's giving us the true depth. All right. So they gave us the true depth right here. I'm going to switch to highlighter. Gave us the true depth right here. And it says that it's going to be 2 feet. And it says, what's the probability that the depth measurement? So remember, what's the depth measurement? Depth measurement is D plus E. So in other words, what did they just give us? They gave us the true depth, D is 2. All right. So remember, if we're looking, that is a regular M, not a mean symbol. They just told us that the true depth is 2 plus the measurement error. And in this case, the measurement error is what we know to be normally distributed with a mean of 0 and a standard deviation of 1.5. Now, here is the deal. That means we need to know how a distribution is affected by adding a constant. All right. And we know that the mean of any situation, all right, if the mean is 0 and we are just adding a constant to the entire distribution, then you just add that same constant to the mean. That means that the mean of this situation is just 2 because we started off with 0, we were adding the constant 2, so the mean of the whole distribution is 2. Now, here's the funny part though, is that for standard deviation, all right, adding a constant does not affect your standard deviation. So we do not add the 2 to the 1.5. The standard deviation here will just stay 1.5. So this was an incredibly confusing setup question. It essentially told you that the depth measurement was made up of 2 variables, but it told you that one variable was normally distributed with a mean of 0 and standard deviation of 1.5. So it essentially set up a distribution for you. And then it told you the second letter, the D, was just 2. So it set a set point of 2, which means that it was adding a constant to the distribution they set up. So I know that can seem really confusing. MrCaproni, how did you know? It's just because I've worked a ton with this. So once you start having an understanding of the whole class, you kind of start to remember some of those old things and how you can pull them back forward here. Now that we have this information, we can actually answer the question. So it says, if the true depth at a certain point is 2 feet, what's the probability that the depth measurement will be negative? Well, we know that this is normally distributed. All right, so we can use our normal CDF here for the probability. And we will just use 2 and 1.5 as our mean and standard deviation. So we're going to go to our calculator. We're going to do the menu 5 normal CDF. But where will we set our lower and upper bound here? Well, it says in this situation that we want to know the probability that it will be negative. Well, what numbers are negative? Anything below 0 is negative. So that means that our lower bound is going to be as far below 0 as we can go, so the negative 99999, and the upper bound will just be 0 because we don't have to worry about going past 0 because then you're in positive numbers. We want everything less than 0, so we're going to go negative 999 up to 0. All right, so let's go ahead and switch over to our calculator. We said that we want to do menu 5. We're going to do normal CDF. We said we're going to go from, yep, that's fine. We'll leave that in as that. And we're going to go up to 0. But in this case, our mean is 2. And we said that the standard deviation is 1.5. We hit OK. We find out that it is 0.091211. So whoa, we don't want to do that with a highlighter. 0.09, and now I forgot, was it 1211? Yeah, 1211. 1211. 1, 1. So that's going to be the answer to A. Part B says, suppose 3 independent depth measurements are taken at the point where the true depth is 2 feet. What is the probability that at least one of these measurements will be negative? So it says, suppose 3 independent depth measurements are taken. So 1, 2, 3 independent depth measurements are taken, where the true depth is 2 feet. So in other words, they're talking about this situation in A, all right? What is the probability that at least one of these measurements will be negative? This is actually talking about our multiplication rule from the probability chapter that we did. So remember, that means we can find the probability of each one individually, then multiply them together. But we also learned that the words at least one tell us that it's going to be a trick. Instead of finding each one individually, we're going to find the probability of this not happening, and the answer is going to be 1 minus that. Yes, like I said, this is a challenging question that is going to test you over a whole bunch of chapters. So again, we are getting ready for this AP test where they will just throw everything at you in one question, all right? So again, let's go ahead and go through this. It says the probability that at least one of them will be negative. Well, the only way that at least one would not be negative is if they were all positive. So what's the probability of all being positive? Well, remember, in our calculator, we found the probability of being negative. So if I want to find the probability of being positive, I can just do 1 minus that answer. All right, so we're going to bring that down and hit enter. So this is the probability of being positive. All right, now here's the issue. So that's 0.91 essentially. All right, we'll go ahead and use the exact in a second. So that means the probability of this one being positive is 0.91. The probability of this one being positive is 0.91. The probability of this one being positive is 0.91. So the probability that all three would be positive is if we multiply those together. So let's go ahead and multiply this together. And like I said, I'm just going to go ahead and put this in as 0.91 for right now, just to go ahead and save us some time. 0.91 times 0.91, and you hit enter, and our final answer is 0.753571. So why don't we go ahead and just round that as well and go with 0.75 for right now. So what is the probability that we will get at least one of them to be negative? The probability of all of those multiplied together is 0.75. That's the probability that all three will be positive. So we still need to do the 1 minus to get that answer, which means the probability that at least one of them will be negative is 0.25. And that would be a rounded answer. So maybe we want to make those squigglies just to show that we rounded things. All right. So again, that was nothing to do with this chapter. That was all old stuff. It wanted to know the probability that at least one of them would be negative. We took the answer from this guy was the probability of being negative. So then if we want to know at least one, we found the probability that none of them were negative. So that was the 0.91. We multiplied by itself 3 times since we're dealing with 3 independent depth measurements. That gave us the answer of 0.75. We went ahead and did 1 minus that to go back to the idea of being at least 1 instead of being all positive. Okay. Moving on to C for the last bit of this. What is the probability that the mean of the 3 independent depth measurements taken at the point where the true depth is 2 feet will be negative? So it wants to know what's the probability that the mean of the 3 independent depth measurements taken at the point where the true depth is 2 feet will be negative. So here's the deal. Because our original thing is normally distributed, we don't have to worry about a sample size because this one has a really small sample size of 3. But this is talking about finding out if a mean of 3, of a sample size of 3, would be negative, which means we are actually doing the top question again, except in this case, we want to do it with the sampling distribution mean and the sampling distribution standard deviation. So remember, the mean stays the same, and the sampling distribution is just n divided by the square root of 3, which in this, or sorry, it should be the mean, the old standard deviation. Old standard deviation divided by the square root of your sample size, which is n. So in this case, that would be 1.5 divided by the square root of our sample size, which is 3. So let's find out what that standard deviation is. So we're going to do 1.5 divided by the square root of 3, and we're going to get our answer of 0.866025. Okay. Now, what do we actually want to find here? We want to find the probability that that mean will be negative. So what are we looking at here? We are looking at a menu 5, 5, normal CDF. We are finally doing a sampling distribution question. We want to know the probability that it's negative. So just like before, that means we're going from negative 99999 up to 0. We know that the mean doesn't change. It stays to be 2. And the standard deviation in this case is this thing we just found, which is 0.866025. And we hit OK. And the probability of the mean of the 3 of them being negative would be 0.010461. So, whoa, that's not that guy. We already found that. The actual answer to this question is 0.01. What did we say? 0.461. All right. So again, that's your final answer. The mean that the three independent Dist measurements would be negative. All right. So this question literally went to an old normal CDF question up to the probability chapter question up to the sampling distribution question. So this is exactly the type of question you're going to be seeing on your AP test, where it's testing you over a ton of content in a 3-part question. And there you have it, guys. That is chapter 17 all the way through. We did our multiple days of notes. We did 3 videos of review, including 2 days of bookwork and 1 day of extended responses. And now we will be ready to move on to the next chapter, okay? I'll give you guys a bunch of more information on the next chapter when we start doing those videos. But for right now, go ahead and look over the next few days. I'll go ahead and add a extended response type question for you guys to do on your own to turn into me for your credit for this week, all right? As always, I hope you guys are staying fit, staying healthy, and have a wonderful week.